Have you ever spent hours training a machine learning model just to realize that it actually got worse over time? It's a super common problem, but thankfully there's a simple, really elegant technique that can save you a ton of time, resources, and actually get you better models. It's called early stopping. So let's dive into this powerful little tool.
All right, so here's our game plan. First, we'll tackle the main problem that early stopping solves, which is overfitting. Then we'll introduce the solution itself, get into how it works under the hood, see how to pop it into your code in just a few lines, and wrap up with some best practices so you can start using it wisely.
So let's kick things off with the villain of our story, overfitting. This is what happens when your model gets a little too good at its job, but in all the wrong ways. You know, we kind of have this built-in assumption that the more a model trains, the smarter it gets. But is that really the case? Well, the answer, maybe surprisingly, is a big no. Pushing your model for too many epochs can actually make it perform worse on new data it's never seen before. Let's take a look at how that happens. Okay, let's just follow the numbers here. Check out the training loss column. See how it just keeps going down and down and down? From the model's perspective, it's crushing it. It thinks it's getting smarter every single epoch. But now look at the validation loss. That's the model's real report card. It gets better for a while, it hits the sweet spot right around epoch 30, and then it starts to go up. That is the exact moment of overfitting. The model has stopped learning useful general patterns and has started just memorizing the noise in the training data. So the punchline is, our best model wasn't the last one. It was the one all the way back at epoch 30. So how in the world do we stop our training at that perfect moment? I mean, you could sit there and watch the logs, but there's a much, much smarter way to do this. So let's meet the hero of our story, early stopping.
Seriously, just imagine for a second that your model had its own little supervisor, watching its performance on every single epoch and just knowing the exact moment it peaked. Well, that's literally what early stopping does. It's such a simple idea, but the impact is huge.
So the official definition is that early stopping is a type of regularization, and regularization is just a fancy word for any technique that helps prevent overfitting. It works by keeping an eye on the model's performance on a separate validation dataset, data it hasn't trained on, and it basically just pulls the plug as soon as that performance starts getting worse.
Okay, the concept is pretty straightforward, right? But how does it actually work? Let's get into the mechanics, which all revolve around one really important idea: patience.
The whole process is incredibly logical. First, you tell the model what to watch. Usually, that's going to be your validation loss. Second, you give it some patience. This is the magic number. It tells the model how many epochs it should wait for things to get better before it just calls it quits. If the validation loss doesn't improve within that patience window, training stops. And here's the best part. It automatically restores the model weights from its best ever epoch. So you're left with the peak performer, not the overfitted one. Simple as that. All right, that's enough theory. Let's get this into practice. You're going to be shocked at how little code it actually takes to get this up and running in a framework like Keras. It is literally just a few lines of code. First, you import early stopping, then you create it. Here, we're telling it to monitor the validation loss, we're giving it a patience of 10 epochs, and, this part is absolutely crucial, we're setting restore best weights to true. And that's it. The whole thing is configured. And actually adding it to your training process is just as easy. When you call model.fit, you just pass your new early stopping object into the callbacks list. That's it. Now your model has that intelligence supervisor we were talking about. You can set your epochs to a high number, like 100 or even 1,000, and just trust that early stopping is going to find that sweet spot and stop the training for you. So now you know what it is and how to use it. Let's just wrap things up with a few best practices to make sure you're getting the absolute most out of this technique. Okay, to really use this well, just remember these 4 things. 1, monitor a validation metric. This is non-negotiable, right? If you watch the training loss, it's never going to stop because it's always improving from its own perspective. 2, patience is a hyperparameter you'll have to tune. Too little and you might stop too early, too much and you're just wasting time and electricity. 3, always restore the best weights. That's the whole point. And finally, don't just use this by itself. Combine it with other great techniques like dropout to get even more robust models. Early stopping is just a perfect example of a beautifully simple idea that delivers huge value in machine learning. It saves time, it prevents overfitting, and it often just gives you a better model with almost zero extra effort. Which kind of makes you wonder, right? What other simple, fundamental tools are out there just waiting to unlock your model's full potential?